Hi all, in this lab, let us understand one more modernization pathway which is refactor. Okay, so in the refactor, we'll be using one more AWS service called AWS Migration Hub Refactor Spaces. Let us get started. So if you recall, this is the last architecture that we have created so far. We have the front end hosted in S3, the app layer hosted in App Runner, and database is hosted in Aurora MySQL database. Okay, so from monolithic to this kind of a architecture that we have developed in the cloud. Now, going forward, what we'll be doing is if we wanted to split the traffic between the monolithic and the new microservice that we wanted to develop, let us say we wanted to factor one more component into a separate microservice. Out of monolith, if you want to create a separate microservice for that particular component, then how do you ensure that the traffic is shifted seamlessly to that new microservice? So for that, we'll be using a pattern called Strangler fit pattern. So to implement the Strangler fit pattern, we will be using the AWS Migration Hub Refactor Spaces service. Okay. So for example, this is one more service called Migration Hub. Within the Migration Hub, we'll have Refactor Spaces. Okay. Refactor Spaces is one more feature of the Migration Hub, and within that, first we have to create an environment. Okay. Environment will model the entire application infrastructure setup. So for example, when you create a default environment, it will create a API gateway. So API gateway will front end the user calls and does the traffic routing. So then we will create an application within the environment. And when we specify the application, we also need to specify the proxy VPC. The proxy VPC is where the NLB is created by the service. The NLB is used to do the traffic routing to the different microservices, whether they are in the existing monolithic application or they are the new microservice in the new VPC. So this is how the setup looks like when you create an application. Now we have to create a the VPC integration is already created between the API gateway and the NLB automatically. Then we have to create a service and define the routing to the monolithic application, how we wanted to define the routing. Okay, so in this case, what happened was when you create a service, we have to specify the endpoint. The endpoint is basically the app layer which is running on the app runner service. Okay, so there is an integration between the API gateway and the app runner through HTTP integration. So the app runner is a public endpoint, and API gateway will directly talk to that endpoint using the HTTP integration. It does not go via load balancer NLB. So if the monolithic application is running on a VPC, customer VPC or application VPC, then the NLB will be talking to that particular monolith which is in the application VPC. For that, we have to do the VPC pairing between proxy VPC and the application VPC. So we can also use the proxy VPC same as the application VPC in case if you don't want to create a one more VPC. Okay, but in this demo we are not really using the NLB path because API gateway is directly talking to the app runner service directly. Okay, so this is how the setup looks like. Now from S3 we don't need to connect to the API app runner service. Instead we can directly talk to the API gateway. So the flow is like this. Users will make a call to the web page hosted in S3 using the static web hosting feature, and from S3 it will talk to the API gateway. API gateway will internally route the traffic to the backend, which is the app runner service. Okay. So in this case, we just onboarded a default service. Now, later on, when we created a new service for that component, which we wanted to take out of the monolith and created one more microservice, and then we have to create one more service and do the routing to that service. So that we will discuss in the later lab. But for this, we just learned how to create a migration hub refactor space environment and an application and a service within that to do the routing. Okay. Now let's go to the code and see how to implement this architecture. Okay, so this is the code where we are implementing the Lab4, that is refactor use case using the migration hub refactor spaces service. Okay, so let's go to the code. Now the backend is pointing it to the S3 bucket path where we are hosting the state file. Okay, and as we know, there is a dedicated folder for each project that we are deploying. Okay, now the important part of the code is in the refactor-spaces.tf file. So here we are using this module, and the latest version is 0.0.2 at the time of doing this. So we are creating one environment with the name unistore-dev, and this is a description, and we are not creating any infrastructure like transit gateways or other infrastructure because we are not using any multi-account setup in this case. Okay, we are using a simple setup, same AWS account. But ideally, when we are using the refactor use cases, in production case, there will be three different accounts: one for the environment, one for the monolith, and one for the new microservice. But in this case, everything is in the same account. So after the environment is created, we are also creating an application, and this is the name of the application, and this is a regional. The API gateway which is going to be deployed is a regional service, a public facing endpoint. The other option is a private, but we are keeping it public because we are accessing through S3, and S3 will talk to the public endpoint of API gateway. And the proxy VPC, this is where the NLB and the proxy application proxy will be created to route the traffic to monolith and the new microservices. So here I'm using the same VPC that we have created earlier in the lab 1. Ideally, we can create a different VPC with production use case, but in this case I'm using the same VPC. So that means there is no VPC peering is required because the application proxy and the existing monolith and the new microservice, all the three are residing in the same VPC. Okay. Now, once an application is created, now I'm creating a service within that application. So here there is application name and this is a service name called legacy, and the type of the endpoint is a URL, and this is a URL for the app runner, and I'm also providing the health check, and this is a VPC ID. Okay. Now, so this is how we are basically configuring the route. So if you look at the source path, this is a default route, and as soon as this particular service is created, we want it to be active. So route active is equal to true. That way traffic can be shifted immediately to the microservice, monolith using the API gateway. So this is a simple configuration using the Terraform module, and let us go and deploy this, and let me call Terraform init in this directory. So init is done. Now I'll call Terraform plan. So Terraform plan is also completed. Now I will do Terraform apply with auto approve. So Terraform apply is also completed. Now let us go and validate the resources which are created in the AWS console. Let's go to the AWS console now. Okay. So we are now inside the AWS Migration Hub service. Within that we have the refactor spaces. So if I go to the environments which are created in this account. So this is the unistore-dev environment that we have created, and this is the ID, and it is saying healthy. Okay, and there is one application and one service. We saw that there is one route. Okay, now let us see some more details. So I'm inside the environment called unistore-dev, and within that I have this application called unistore created, and this application ID, and this is a VPC, this is a proxy VPC that we have configured, and this is a network load balancer. This is created automatically by the service, and this is the API gateway which is also created when we created the environment, and this is a proxy. So the service that we are going to access, that our monolith application is now accessed by the API gateway. So this is endpoint, and API gateway URL slash prod. So this is where it will go into the API gateway URL, and it's a regional endpoint. And within that we have just created one service, okay, and it's called legacy, and the default route is slash. Okay. Okay, now let us go to this URL and see whether it is working or not. Okay, so in my browser window, I have entered this URL. If you look at this, this is a API gateway URL slash prod. So this is what we have seen earlier, the proxy URL, and slash unicorns is what I've appended. Okay, so this is working fine. So that means the request when it comes to the API gateway to this particular proxy path, and if I put slash unicorn, it is basically going to the app runner. App runner will be talking to the database and getting all of this details. So that means the integration is working fine between the API gateway and the app runner service. Okay, now let us look at the complete application flow now. So currently I'm running this on the EC2, but the same application is available on the S3 bucket also. So I updated the path to the API gateway both on the EC2 and also the S3 bucket. Okay. Now, if you look at that the application is working fine, so you can see all the um, details from the database. So this is how we can connect from S3 to the API gateway to the app runner and the database together. Okay, just to confirm also, let me just log in also. I've already logged in the previous case. I just logged in and added a few things to the cart. Let us just enter my email and password and see if I'm able to get all the data back. So I logged in and there are two items in the cart. So that means the database is already getting accessed and everything is working fine. So this concludes the demo for refactor use case to use the AWS Migration Hub refactor spaces service to be able to shift the traffic to the monolith via API gateway. Okay. So in the next lab, we will be implementing a microservice and do traffic shifting very seamlessly from the end users. Okay.